we've looked at some of the methods for hunting for planets around other stars. Now let's just briefly look at some of the extraordinary types of planets that have been discovered around other stars. Well, when these hunts first began, the first types of planets to be observed were planets called hot Jupiters. These are planets the size of Jupiter, but orbiting very close to their star. And the reason why these were first discovered is because they're large and they rotate around their star in short time periods, which made them quite easy to detect. In fact, the first hot Jupiter to be detected was in 1995, around 51 Pegasi. There are many hot Jupiters that have now been discovered. One question is how these giant planets got so close to their star, and one theory is that they migrated inwards from the outer reaches of the star system where they first formed. It doesn't necessarily preclude the possibility of Earth-like planets that could still be formed further out in the star system. But hot Jupiters are certainly not habitable. They're much too close to their star for that and much too hot. Some even more extraordinary planets have been found that are bigger than Jupiter, and we call these puffy planets. Some of them, such as Kepler 7b, half the mass of Jupiter, but 50% bigger. And this planet, Kepler 7b, orbits its star every 5 days. It's very close. It orbits a star near the end of its life in the constellation Lara, and it has a density the same as polystyrene. No one really knows what its composition is. It probably has hydrogen and helium and maybe some other components. But these are Jupiter-like planets with very low densities. Another type of planet that's been discovered are called hot Neptunes. These are planets that orbit very close to their star, but they have a mass more similar to Neptune or Uranus than Jupiter. The first one of these planets was discovered in 2004, called Gliese 436, and it orbits its star every 2 days and 15 hours. It's thought that this planet may be made of ice, but that doesn't really account for its radius. It could be a super-Earth, a giant rocky planet, but have layers of hydrogen and helium, which would account for its density. Now, some really strange planets that people have speculated about are called carbon or diamond planet. These are planets that form around stars that are rich in carbon. What would these planets look like? Well, they could have layers of diamond, graphite and silicon carbide. And in fact, there may be so many diamonds on these planets that they may have volcanoes erupting diamonds that form mountains and canyons of diamonds. And the first type of planet that might be a candidate as a diamond planet was discovered in 2011. And it's the remains of a star found orbiting a pulsar, a rotating neutron star. And this may be the first diamond planet. Further observations are really required to confirm this, but it shows that there are planets that are very unlike the sorts of planets that we see in our own solar system that might be orbiting other stars. Other types of planets that might exist out there include water worlds. These are planets with a surface completely covered in an ocean. And the first candidate for a water world was discovered in 2009, JG1214b. This is a small planet with a very low density that may have a thick gas atmosphere, but it could have a rocky planet beneath that atmosphere. No one really knows quite what its composition might be. It could be a mini Neptune, but it could be one of these elusive ocean planets. On such a planet there might be water as steam, plasma phases of water, even high-density ice forms of water, as well as a surface ocean. The spectroscopic studies of this early planet show that it's featureless, and this featurelessness could be caused by water or clouds in its atmosphere. Well, those are just some of these strange worlds that astrobiologists are hunting for around other stars. But I think it's true to say that the planets that people are really interested in are those in the habitable zone. And we met the habitable zone earlier in this course as the region around a star where temperatures at the surface of a planet are sufficient to sustain liquid water, places that might be conducive to life. The distance of the habitable zone will vary depending upon the star. The hotter the star, the further the habitable zone from the star because of the heat given off by the star, and therefore the greater distance at which liquid water can be sustained on a planetary surface. So what are we looking for in the habitable zone? We're looking for rocky worlds, terrestrial-type planets that could host liquid water on their surface. The first rocky world was discovered in 2005, Gliese 876d. It has a mass just over 7 times the size of the Earth, and it seems to be what's called a super-Earth, a large rocky planet. It's about 15 light years away. In 2007, yet another planet was found, Gliese 581c. It's nearer the habitable zone, but it's too close into the star, and tidal heating may keep the planet molten, so that doesn't seem to be a prospect for life. But these early rocky worlds showed that we can detect terrestrial-type rocky planets nearer the habitable zone around a star. Only recently have planets been discovered that really fit in that habitable zone. Gliese 667c was discovered in 2012. It's got a mass just under 4 times the Earth, and its description was published in the same year. This is the first planet, really, to be found in the habitable zone, and a planet that could have liquid water on its surface. And it raises the tantalizing possibility that we're very close to the possibility of finding Earth-like worlds around other stars where there could be liquid water, the sorts of candidates for the search for life. There are some other types of planets that astrobiologists have also been looking at around other stars. There are even planets in binary star systems. Kepler 16b, for example, was discovered in 2011. It's a gaseous, cold planet outside the habitable zone, and it seems to be about the size of Saturn. But it was the first planet to be found that was orbiting 2 stars, proof that planets can exist in stable orbits in multiple star systems. It also raises the interesting idea of rocky planets that could be found in binary star systems, planets where there may be even life with 2 stars. There have been a very large number of planets detected to date. This is a graph where you can see the planet mass plotted against the year of discovery. And as you can see, an ever-increasing number of exoplanets. But what's more interesting about this graph is you can see that the planetary mass is decreasing year by year. In other words, the methods for finding exoplanets are becoming much more sophisticated. And as they become more sophisticated, we're finding smaller and smaller planets, pushing into the realms of Earth-like planets orbiting distant stars within the habitable zone. Certainly the most exciting possibility for astrobiologists. So what have we learned in this lecture? Well, hopefully what we've learned is that there is a zoo of planetary types out there, a whole variety of different planets orbiting other stars. Most of them are not going to support life. They're very different to planets that we know in our own solar system. Some of them are too close to their star, they're probably too hot to support life. Some of them may be too far out and too cold. But as methods are improving, we're beginning to find smaller rocky planets that may be discovered in the habitable zone. A third of planetary systems may have rocky planets in the habitable zone based on the observations that we have so far. And rocky planets can orbit a variety of different stars, and there may even be rocky planets orbiting multiple star systems. So this is a very exciting time for astrobiology and the search for Earth-like planets around other stars.